Good evening, students. We're going to look at how recursive formula differs from function form. That's our essential question here. Right here you see two odd notations. A sub 1 means the first term, or term at the first position. A sub n means the term at nth position, or any position. So if you'll notice, the term at the first position is -4. Then you look at the formula, which means you're just going to add 5 each time, which is a common difference of 5, which means a lot. And so when they say nth position, means it just keeps on going into infinity. Sometimes they'll put a number there. They don't always use a. Often mathematicians use a t for term. But to me, a means a term. So if you have a sub 1 equals 6, the t sub 1 is going to be 6. It transfers perfectly. And t sub n, notice you just had, the only thing that's changed is the t and the a. That's it. In both terms, in both series, you notice that they're adding 3. So the first term is a 6, and then you keep adding 3 each time. Now let's look at these. Freeze this and try to do it without me, and then turn it back on. Hopefully you're back. The first term is 2, so you put a sub 1 is 2, and then a sub n equals a sub n minus 1 plus 10, because the n minus 1 means the term before it. So you're adding 10 to the term before it. And here we go. Look at this one. See if you got that right. Now you really do need to practice doing these because it's too simple to miss this. Now let's look at series. I don't know why this frame comes up and I wind up having to. We are going to do some of the series, but I'm not going to have time in this video. So let's look at this first problem. It says the first term of an arithmetic sequence is equal to 6 and the common difference is 3. So if I write that in recursive form, I do a sub 1 is equal to 6 and then a sub n is equal to a sub n minus 1. You have to memorize this part right there and just put plus 3 because the common difference is 3. Now if I write that in function form, which I find far more pleasable, is that a word you think? Pleasant? I don't know. Is y equals, if the common difference is 3, it's going to be 3x. To figure out what the y-intercept is, that's the 0 term, right? Because if 6 is the first term, 9 is the second term, I just need to look at the 0 term, and in this phase, it's going to be y is equal to 3x plus 3. So it's really easy to find the 50th term. If x is a term position, well then by golly, I'm just going to put 50 in for the x, right? So all you have to do is put y is equal to 3 times the 50 plus 3. It's a lot easier to find the the 50th term or any term if you just use the function form. So here it is in recursive. A sub n is equal to 200. Oh, I meant to put a sub 1. I meant a sub 1 is equal to 200. Doggone it. And I recorded this writing before I'm recording the verbal part because I forgot the headphones at home, so I'm at home right now. Okay, so if I write it in function form, of course my first term is 200. My second term, because I'm subtracting x each time, is 190. So the 0 term would be, going backwards, 210. And it's a positive 210. So if I found the 50th term, I simply put a 50 in for the x, and that's going to give me negative 500. Plus 210 should be negative 290, right? Let's hope so, because I made a mistake on the last video, that a bunch of y'all called me out on. Here we go. Now notice this one, you have to read them correctly. This time they give me the common difference first. So a sub 1 is 8, and a sub n is equal to a sub n minus 1 is equal to 14. So don't get so tied up in not reading this that you miss something so simple. So it's y equals 14x, and I'm looking at my first term being 8, the next term is 22, then 36, and I'm going to go backwards by subtracting 14, I get negative 6. So there's my function. I'm going to try something. I'm going to try the second point to make sure I did this right. 14 times 2 is 28 minus 6. Yeah, I just want to make sure my output was the same, that I didn't mess something up. And now I'm going to write the 50th term. Well, 14 times 50 is the same thing as 7 times 100, right? So it's 700 minus 6 is equal to 694. Now freeze this, please, and try this. Okay, I hope you're back and you see that this is worded altogether differently, but I want you to understand that the fifth term position is x. So you know that the term is 5 and the output is 22. So it's just like a coordinate. That's all you got to do. And the 15th term is 72. Hey, let's find this formula. If first you find the slope and then put it in point slope form. Please freeze this and try to do it now. Hopefully you're back, and the changes in y were 50 while the changes in x were 10. That gives me a slope of 5. I'm going to put it in point slope. Please do this. You need the practice. So y minus 22 is equal to 5 times x minus 5. Now I just solve for y, right? So let me distribute the 5. 5x minus 25. I add 22 to both sides to isolate the y all by itself, and I get 5x minus 3. And so now I have the function form. If I want the 50th term, you know what to do. Are you staying out there? Are you talking along with me? Yeah, we just put the 50 in for the x. Good for you. You know what to do. I'm putting it in recursive form. If I need to find what that first term is, I just used 1 for the x. And the 50th term is 250 minus 3, which is 247. Okay, last thing. Did you see the Math Counts video?
Right.
Now notice that if you find the sum of the first 60 numbers, 1 plus 3 plus 5. Oh, you know what? My husband just came in here and said he's going to take me out for Mexican food. So I'm going to stop this now, and you guys have a good evening because I'm going to go eat a taco. You take good care.